All right. Hopefully you guys can see my screen. So normally the way I approach most of my sessions is I always have real life use cases, and then I walk through building out all the components that are required to deliver a solution for the business, right? So it's more like, okay, I'm taking a use case, but business comes in, a business requirement is what we're trying to satisfy, but we're gonna have to build that end to end. So the advantage of using this is that you have some real value that you're gonna get out from the solution as presented today. So let's just go over the use case, and we then go over how we're going to solve the problem. Then we can start building out all the capabilities in Azure. Now, if you're brand new to Azure, I'm going to be obviously this is a recorded session, so to give you an opportunity to actually get your feet wet when you try to start using Azure. So we're going to walk through that as well during the process, and I'll explain each resource I'm provisioning as well, and then I can begin go over why we need those resources during the implementation process. So the use case here is we're going to create a centralized database that stores and manages all contact information for college. So take all the colleges in the United States. We're going to try and build a database for that. And we have to ensure that it's secure. We're going to have to provide some ingestion solutions because we're going to be handing something over to the business, the client who's going to be uploading the information. So we have to expose an API so it's going to upload data. And we also have to expose an API, a secure FTP to move large data sets. So they're going to test it out with a couple of records and they're going to have to move large data sets. So anything over 100,000 records, we don't recommend using an API. We recommend using a secure FTP. So they've agreed that this is the solution that they're going to go with. Some of the actors here, if you're familiar with how this works, is that you have a colored administrator whose job is to upload all the contact information by one of these two options. The integration we're going to be building out today is going to be doing data ingestion, processing into storage, and then this is just basically the end users that are going to be using it. Some of the benefits of the solution we're going to present today is that we're going to solve a couple of problems. They don't have sporadic databases out there because now we're going to ingest them and put them into one centralized system. Then also we're going to be using the supports. We're going to give them the flexibility to choose what option they want to be able to upload the data depending on the size. And automation pieces, we're going to see that along the way. So we're going to talk about automation, scale, security, and if we have time, we do some reporting. Now, this is just basically a diagram I put out here so you guys can actually have a look at it. It just basically talks about what we're going to build out today and how the flow is going to look like. In terms of Azure, we're going to be building a storage account. We're going to be building out this is going to be baked in. The eventing system is baked in, so we can talk about it as we're using it. The Azure function we're going to build from scratch. Service bus, we are going to build that from scratch as well. And we're going to show how messages are flowing through from the function app into the service bus queues. And then we're going to be building out the database finally, which is going to be exposed to the end user so they can pull data back in. Um, the scenario here basically is an administrator uploads a CSV file from containers containing new students' contacts by SFTP or via the API. In this case, SFTP is the final product. And then the storage account is going to be triggered to once an upload is picked up by the secure FTP. So it actually pushes it out to relevant places, including the service bus. So we see that in action today. Now, this is just basically an architecture diagram that shows this. And I'm going to put this in the chat so that way you guys have access to it. It's a public repo. So all this stuff I'm showing here, you should have access to that as well. So let me put that in the chat for you guys. This is just basically showing that a diagram of the end-to-end, what we're going to be doing. So we're going to be building like secure FTP, like we talked about, is going to be put into a storage account. There's going to be a trigger that's going to be listening to this storage account, picks it up, pushes it out to another container, which is going to be doing all the parsing, and then it will get triggered and pushed out to a service bus. Because we're going to be moving a lot of files, I want to make sure that we can shard the files into manageable sizes because remember, messaging only has a cap. Every messaging platform has a cap. Mostly is around 1 meg, which is the max. So we have to chunk the files in certain sizes so we can put them on the service bus. So that's something we're going to do to accommodate the solution that we're looking for. And then finally, we're going to put into a SQL database and also a NoSQL database we're going to introduce along the way. This session is recorded, so I have a previous recording here if you want to go and look at it. Some other things that we're going to be covering, which is in line with all the industry standard products that are out there today in Azure, is things like Azure Data Factory, Databricks, and Synapse. You hear that if you're into any kind of a data ingestion, you must know about one of these three platforms today. We're going to basically what we're doing is we're going to mirror what they have, but we're going to build our own solution out today. So we're going to have a data ingestion, which will take care of ETL. We're going to have pools. We're going to have dedicated pools in SQL. So I'm going to show you how that works. And then for data ingestion, we're going to have our APIs are going to be Azure Function, which is going to be connected to storage accounts for our data ingestion and data processing. We're going to have workflows for that. So talk about the workflows as we go along. Programming language is going to be T-SQL.NET. Scaling is going to be baked in. So as we provision the actual container apps that's going to be have a code in there, this is automatically going to be scalable, and you see that in action today as well. Manage pools. We're going to build out the whole SQL, and we're going to show where how all the scaling works. So you will see the capability there if you guys are interested in using Azure SQL. And all this is just talking about the different services we're going to be using today, which is going to be the Azure services like Azure SQL, Blob Storage. There's a couple of more ones in there, but I just called that a copy here. Data movement, I kind of talked about that. We're going to copy data, move it, slice it, transform the data across all Azure resources. Well, technically, yeah, we're going to be hitting the Azure function, storage accounts, Service Bus, and SQL. So all the resources we're provisioning, the data is going to touch each one of them. As far as orchestration goes, we're going to be using event-based triggers. Similarly, it's actually interesting. We drop files, it gets triggered, someone else picks it up. So we're just basically handle responsibilities to individual workflows so they can execute it. It's almost like a microservice solution because no one person owns the whole pipe. We just it's almost we're passing work on from one person to another. So that's the whole goal of orchestration here. ML is just something that I put in there. It's an extension of the features that we have. Microsoft has this baked in now, so I'm not too worried about that. And in the web, for the web-based, we're going to be using SQL to query our data. And we're going to talk about VNet integration or what we call virtual network integration, but we're not going to be actually applying that today because we don't have a virtual network set up. And we're going to be doing ETL, which is basically what you guys are used to. I'm going to do ELT. ELT basically means that once the data is actually loaded into the backend database, there might be some transformation that's required to pull the data back out. So the client might not want the data that's actually in the database in the schema that it is. They might have a different schema representation for what they're trying to present. And what we're trying to do is that we can provide a way to extract that data and then do some transformation in real time. Pay-as-you-go is basically the cost we're going to be using. So everything we provision is pay-as-you-go. There's no real dedicated servers. Most of them is going to be as you use them and you need them. These are all the different ADF ingestion sequence that we have today in comparison to what we are building. So for ADF, they use secure FTP to a storage account to ADF, then picks it up from a storage account and puts it into a database. That's kind of standard practice. Databricks is similar, but it has a job API that actually helps to move the data along. So there's an API in between the two that actually pushes it to the database, or you can push it to Azure Storage. This is a one that most people use, but you have to have a lot of programming knowledge in Spark or Python to actually get that going. Synapse, a little bit more extendable because Synapse has a combination of bricks and a combination of ADF. It's kind of like what Microsoft put together. So you can do a data lake, or you can use Azure Synapse. You can use PySpark, which is basically a notebook that's similar to what Databricks uses. And you can push it out to SQL as well if you wanted to do that. So that's kind of all the things that those are all the existing technologies that we have today. And we're introducing ours similar to what they have, but we're using a different flow. So these are the steps. A Azure SQL database, Service Bus. We're going to build those two out. API is serverless APIs. We're going to build that out. Service Bus, and the triggers are basically just some of the operations that come out from the Azure Function application once they're built. We're going to implement error handling, so that's going to be baked in. You might see, depending on things work, you might see some errors that pop out, or we can actually do some validation. We're going to secure our functions as much as we can in terms of not necessarily using Active Directory, but I recommend that if you're in a enterprise environment. But we're going to have some API keys that prevent just wide open access to APIs. And one of the things we're going to introduce here is CI/CD. Now, I know we have an hour and a half, so a lot of this stuff is going to be moving very quickly, but we're going to try and cover as much as we can as we go along. And then hopefully, if you guys have time, once this recording is available, you can go back and actually look at it. All right, so we can get started. Let me scroll down to some of the prerequisites that are required before we get going. Let me hide this. So if you're new to Azure, it is your first time and you're trying to get into this space, some of the things that you can get for free, which I don't have because I've been using Azure for a while, is the credits. So I recommend that try Azure for free when you have time. They do offer $200 credit take advantage of that. You get that for a month, then you will get they're actually adding more and more services for free. Some of the stuff here is AI related, it's just AI related stuff. So if you want to leverage the $200 credit to run some AI stuff, I recommend doing that. Then what happens is that this flips over to a pay as you go, but you still get 12 months free services before they charge you fully at the full price. So that's one of the things I recommend if you starting in Azure. And if you're starting on VS, if you're doing some coding, just assume that you've gotten past and you know you're ready to start coding and pushing things out. I recommend using either Visual Studio Code for the full IDE, which is pretty big. I mean, and then you download the free version. These two are technically trials. This is 100% free. The Community edition is completely free. Or if you're more comfortable in the VS Code space, recommend downloading the one that matches your operating system. I actually use VS Code more these days because it's a little bit more flexible, it's lightweight. This is a little bit more involved, and this is for really more intricate development if you're trying to do more in development work here. And what else? Some other things we're going to be using along the way is Postman. If you're not familiar with Postman, it's pretty much most of the API products out there are mostly most customers are actually starting to use Postman because they have two options. You have the Windows version, which is you can download. The advantage of Windows is it starts up quicker, but the disadvantage is that any additional updates you have to wait for that to come out. So I tend to use the web one, and they always say try the web version, which is what I use. Or I get all the updates in real time. So I recommend using that if you can. And if you haven't heard of Liquid, Liquid is basically something that I use. Shopify uses it, so it's actually a very good product. It allows you to transform data. It's actually interesting. Actually, you can take raw JSON payloads and you can actually do real-time ETL transformation with it. So this is something I introduced, and we have a chance we can actually see how that will clean up our data as we get data back up from our system. And the rest of them is self-explanatory. We're using configuration-driven development, so we're not going to be doing a lot of coding, basically. We're going to be focusing mostly on configuration, so don't be worried if you don't have any coding experience. You still can actually get this deployed and do some customization if you needed to do that in your environment. So some of the advantage of going this route is that we have configuration files. Developers can easily tweak and adjust. If you're not even a developer, you can tweak and adjust the config files. Very, very straightforward. There's a separation of configuration from code, meaning that all the configuration is isolated. Changes can be made without you having to do new deployments, so no downtime. So imagine being if you're in production, you don't have to take any downtime if you want to push out some additional coding. Scale, very, very good for scaling. So we can scale across multiple function operations or apps if we wanted to with the same code base. Testing and validation becomes very easy. So we show that today how we can test and validate some processes that we're using. You can do domain specific customization, but this area will focus on more data. So how do we communicate with two different systems under the same API? So we'll probably have a look at that if we have some time. Or we can get started, right? So this same URL which I shared has the code base as well in it. So this is the code base that we're working with today. I already forked it locally. If you guys are familiar with GitHub, you can click on the code button here, and then you can either open it up in your GitHub desktop, or you can use Visual Studio Code, which is what I recommend, or you can use code spaces, but be careful with using code spaces. There's a cap on it, so you only get 30 days, I think, and you have to pay for it. So I recommend download it locally, then making your changes and check it in the normal way. Now, once you download that, it looks something like this. It's just basically, uh, I'm using dark mode right here, but you can have light mode. And in dark mode, you just have a couple of files. These are the config files which I mentioned because I said, it's configuration driven development. So we're not actually going to. This is the config files I've been manipulating as we go along the way and do some testing. Some boilerplate code here, triggers, everything is boilerplate code. There's no need to change it. The only change that you make if you're using in your environment is the type of GUIDs you're going to be using because these GUIDs are customizable, right? So you can make up your own and then put your own flows in there. So there's a lot of flexibility between the two, right? So a good example is this GUID is in here. I can just actually quickly look at it and then it tell me what it's doing inside of this flow. So these are what the flows look like. Data flows are very simple. Each data flow represents each step in the process. Then you can go and add each step as you go along. And each of them is a circuit breaker, meaning that you can actually turn it off. If you don't want to step, you just turn it off. So that's how that works. The rest of them is basically boilerplate code as well. No need to touch it. It's more like it can deploy as is. Now, the way it's set up is that if you deploy your environment, you can easily start, you can repeat what I have and get going to start pushing things out. All right, so now that we've downloaded this, how do we get this into Azure? That's the next question, right? So let's go over to the portal site, show you what that looks like. Let's go over here. All right, so if you've never used Azure before, I'm going to start from scratch. I probably already logged in, so it's not going to ask me for credentials, but yeah, it does actually credentials. When you log in, the assumption is that you already self-pay your credentials and attach it to your portal. So you need a corporate account or you need a Hotmail account. Those are the only two you can use. It's very difficult to use any account outside of a corporate account or a Hotmail account. Yeah, I think Gmail you may be able to use actually. So try Gmail, but I know Hotmail is a definite yes, and I'm not sure that your corporate account actually works. When you do get into Azure, the top level is always a subscription or tenant level, but in this case, for you, there's the subscription, which is then your roots. And inside of your subscription, you do have resource groups, which is the next level down. So you have this term called resource groups. And inside of those resource groups, you can have resources. So it's like you have a resource group which you create now, then we have multiple resources inside of that. And that's basically what we're going to be focusing on, the resources in the resource group. So the first thing we're going to do is deploy a resource group in here. Now, the approach I'm taking is I'm going to go do it from here, but you can do from a number of ways. But the easiest way to get started is to build from here. So now you've downloaded this code, you have Visual Studio installed, VS Code installed. There's a couple of extensions that are required to get started, right? So you need an Azure account. And once you have your Azure account, that allows you to authenticate into Azure with your credentials. And when you have this is the one that you need to download. And they keep this up to date. So if there's any new updates, it will let you know. Then you also need to have an Azure function, which basically allows you to deploy your function app into Azure as well. And once that is done, you have something that looks like this. And then if you haven't authenticated, to ask you to sign in, to clearly say sign in here. Then when you get to come back, then you have the subscription. Then you have a boilerplate. You have some boilerplate resources that you can start deploying code into. Now we already have a function app here, which is empty. We want to be able to deploy a brand new function app in there. So the first thing we're going to do is create the function app itself. Then we can deploy the code. It has to be globally unique. So I'm going to start with training. Uh, Training 2024, 12/18. So I'm selected. Hopefully that's available. And then these plans are interesting because these are actual physical machines that represent where your data is, your code is going to deploy to. Now, a consumption plan is basically a vertical elastic solution, meaning that I will have, as I use resources, to spin up additional resources. So I have one machine and I'm consuming a lot of memory or CPU to spin up a second one and a third one and a fourth one for me on a horizontal plane. That means it's beefing up, adding additional servers so I can actually spread the load across all those additional servers, which is a very good option to use. Microsoft takes care of 100% of everything that you need. That's the reason why I select this. The premium and the app service plan, you need some more knowledge around this because you have to configure it yourself. You have to set up the caps on the CPUs and the memory so it automatically spins up machines. And then you have to choose the size, how many physical machines you want to elastically scale to. So if you want to get going, I recommend use the consumer plan. And then you choose your region that is closest to you, which I'm selected. Then whatever language you're using, there's a plethora of languages here, and then you can actually bring your own as well. There's Java, Python. The popular ones are actually listed here, but there's a lot more you can a lot more runtime stacks you can add in here. Operating system is Windows, but you can run it on Linux. I just choose Windows because that's what I'm comfortable with. And then this is where we create our resource group that I mentioned before. We return, and we need a place to deploy our code to, so that's why the storage account is required. So we're going to create that as well. And then we need to be able to monitor our APIs and how our code gets delivered. So this actually basically is an overarching, almost like a way of, or what do you call it, insights into all our APIs. So we can see how our API is behaving, performing, and what's dependent system is touching. So we need that as well. So we're going to create one of those. And then all these steps As you can see here, I'm gonna be executing and pushed out into Azure. So we go over to Azure and see what's going on over there. So I refresh one more time, and I hit this button here. So it's like I'm in my resource group now. So it's created a resource group. Now we have resources that are actually inside of this resource group. Now the app service plan is what I mentioned, the physical machine that's going to be holding is going to be provisioned to hold our function app. And then we can deploy code into, and if you notice, it says Windows over here. So we have a Windows operating system. Then if I do a couple more refreshes, you see some more additional resources getting dropped in